Assalamu alaikum class 9. I hope you're all fine. Today we are going to start our fifth unit, that is gravitation. The first man who came up with the idea of gravity was Isaac Newton. Isaac Newton was the first man who came up with the idea of gravity. It was an evening of 1665 when he was trying to solve the mystery of why planets revolve around the sun. So, basically, in 1665, when he was trying to solve the mystery why planets revolve around the sun, he came up with the idea. Actually, what happened was, suddenly an apple fell from the tree under which he was sitting. The idea of gravity flashed in his mind. He discovered not only the cause of falling apple but also the cause that makes the planets to revolve around the sun and moon around the earth. So basically, in 1665, when Isaac Newton was trying to solve the mystery of why planets revolve around the sun, an apple fell from the tree and an idea flashed in his mind. And there was the first time when he came up with the idea of gravity. The force of gravitation. On the basis of his observation, Newton concluded that the force which causes an apple to fall on the earth and force which keeps the moon in its orbit are of same nature. He further concluded that there exists a force due to which every body of universe attracts every other body. He named this force the force of gravitation. So actually, on his observations of how an apple fell from the tree and how he came up with the idea of gravity, he concluded that the force which caused apple to fall and which keeps the earth and moon around their orbits are of same nature. And he concluded that he found out that there is a force which is causing all this happening, which caused apple to fall on ground. So he named this force the force of gravitation. Law of gravitation. According to Newton's law of universal gravitation, everybody in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to square of distance between their masses. So according to his first law or law of gravitation, everything, everybody, every particular thing in the universe is attracting every other body with a force which is directly proportional to product of masses and is inversely proportional to square of distance between their centers. Consider two bodies of masses m1 and m2. Distance between them is d. So according to his law of gravitation, the gravitational force of attraction with which two masses are separated by distance attract each other. So according to him, the two spheres of masses are attracting each other with a particular force. So according to him, F is proportional to m1, m2 and F is inversely proportional to the distance. So F is proportional to m1, m2 over d square. And here comes the g, that is proportionality constant. F is equal to g m1 m2 over d square. This g is called universal constant of gravitation. So according to law of gravitation, this g is proportionality constant and is called universal constant of gravitation. Its value is same everywhere. In SI unit, it holds the value of 6.673 into 10 raised to power minus 11 Newton meter square per kg square. So this value is same on everywhere. Due to small value of g, the gravitational force of attraction between objects and around us is very small, so we don't feel it. So here's a question like that: why don't we feel that force? And according to law of gravitation, we came to know that this force, this value of g is very small. So because of this small value, we can't feel that force. Since the mass of Earth is very large, it attracts nearby objects with significant force. So mass of Earth is large, so it attracts the significant force. The weight of an object on Earth is result of this gravitational force of attraction. So, law of gravitation and Newton's third law of motion. If you don't forget third law, every action comes up with a equal but opposite reaction. It is to be noted that mass m1 attracts m2 toward it with a force, while m2 attracts m1 with a force of same magnitude. but in opposite direction according to law of gravitation. If the force acting on m1 is considered action, then force acting on m2 will be the reaction. The action and reaction due to force of gravitation are equal in magnitude but in opposite in direction. So it is consistent with Newton's third law of motion, which states to every action there is always an equal but opposite reaction. So let us consider an example. Two lead spheres, each of mass 1000 kg. So both spheres have a mass of 1000 kg and they are kept with their centers 1 meter apart. So the distance between them is 1 meter. So we have to find the gravitational force with which they attract each other. M1 is 1000 kg, M2 is 1000 kg and D is 1 meter. We know the formula F is equal to capital G M1 M2 over D square, and when we put all the values, we got an answer that is 6.673 10 raised to the minus 5 Newton. So gravitational force of attraction is this value. Let's discuss another topic, gravitational field. So according to Newton's law of gravitational force between a body of mass m and earth is given by a formula, which is F is equal to capital G M me over r square. Now here is a capital Me. It is the mass of earth and r is the distance of body from center of earth. So now here weight of body is due to gravitational force with which earth attracts a body. Now gravitational force is a non-contact force because, for example, velocity of a body when thrown up goes on decreasing while on return it's increased. This is due to gravitational pull of earth acting on body. Because a body is continuously facing a gravitational pull, its velocity increases when it comes down, and when it goes up it is opposing that force, so it is not that increasing. Such a force is called field force. It is assumed that a gravitational field exists all around the earth. So now we came to know that there is a gravitational field which is existing all around the earth. This is a field which is actually keeping us toward the center of earth. Gravitational field becomes weaker and weaker as we go farther and farther away from earth. So in the gravitational field of earth, gravitational force per unit mass is called gravitational field strength of earth. So what is gravitational field strength of earth? It is the gravitational force per unit mass. So at any place its value is equal to value of G. Near the surface of earth it comes to about 10 Newton kg per 1.